Well, welcome back to our course on systems design as we look at systems analysis and design, primarily focused on utilizing that for information systems, following the textbook from Dennis, Wixom, and Roth. And this is the last chapter in our second part, our second phase in the analysis phase. And so this is just going to be a dozen or so charts. We talked about data modeling. And now in this short little lecture, we're going to be talking about normalizing that data. And there's like a three-step process that we're going to be using. So three normalization rules. So we'll talk about the technique used to validate the data models, the series of rules applied to logical data modeling to improve its organizations. And the three rules are the first normal form, the second normal form, and the third normal form. So in this appendix, we describe the rules of normalization that help analysis improve the quality of the data model. Those rules help identify entities that are not represented correctly in the logical data model and entities that can be broken out from a file. The result of the normalization process is that the data attributes are arranged to form stable yet flexible relations for the data model. The normalization process is an important step in preparing the data model for actual implementation in the database management system. Typically, three rules of normalizations are applied regularly in practice, and we'll talk about those over the next handful of charts. And we'll describe these three rules and illustrate them with an example. So first, we can talk about the first normal form. And so a logical data model is in first normal form 1NF if it does not contain attributes that have repeated values for a single instance of an entity. Often this problem is called repeating attributes or repeating attributes groups. Every attribute in an entity should have only one value per instance for the model to, quote, pass the 1NF rule. We have the second normal form, or 2NF. It requires that the data model is in 1NF and that the data model leads to entities containing attributes that are dependent on the whole identifier. This means that the value of an attribute that serves an identifier can determine the value for all of the other attributes for an instance in an entity. Sometimes non-identifier attributes are dependent on only part of the identifier, that is, partial dependency, and these attributes belong in another entity. Then there's the third normal form, or 3NF. It occurs when a model is both 1NF and 2NF, and when it is resulting when in the resulting entities, none of the attributes is dependent on a non-identifier attribute, that is a transitive dependence. Okay, well, let's continue to walk through this information. This is a flow diagram, if you will, of the normalization steps. And so we start with a zero normal form. And so if any attributes have multiple values for a single instance of an entity? If yes, remove the repeated attributes and repeating groups. Create an entity that describes the attributes. Usually you will need to add a relationship to connect the old and new entities. And if we have no, then the data model is 1NF. So we have these two possibilities. So is the identifier composed of more than one attribute? If so, are any attribute values dependent on just part of the identifier? If yes, you want to remove that dependency, move the attributes to an entity in which their values are dependent on the entire identifier. Usually you'll need to create a new entity and a new relationship to connect the old and the new entities. And so if there's no to the second question, the data model is 2NF. So you start here and you keep going down this set of rules in this normalization process. Finally, do any attributes values depend on the attributes that is not the entity's identifier? If yes, then remove the transitive dependency or derived attribute. Move the attribute to the identity in which their values are dependent on the identifier. And usually you will need to create a new entity and a new relationship to connect the old and the new. If the answer to this question is no, then the data model is 3NF. So that just gives you a recipe for the steps of normalization. We'll go through a handful of charts relatively quickly just to give us a little bit more perspective of this. So a logical data model is first normal form 1NF if it does not contain any attributes that have repeating values for a single instance of an entity. Often the problem is called repeating attributes or repeating attribute groups. So here's an example for an unnormalized entry. Begin with an entry from the logical data model. Do any attributes or groups of attributes occur more than once for a single occurrence of the entity? And the answer is yes. So we can see this. There's 21 to 22 occurrences of these things here. And so thus, we would want to do some modification. And so we put that into an ordered item. Do any attributes or group of attributes occur more than once for a single occurrence of the entity? If yes, move the attributes or groups into a separate entity. And so thus we can see how that works. What are some potential anomalies that can occur with the first normal form? Insert anomaly. Do we insert a new item? Can we do it without a order number? So we have the insertion anomaly of the deletion anomaly. Assume only one order for item 456. What happens if the order is canceled? Will we lose all the information about item 456? And finally, update anomaly. The price of item 789 changes. What problems occur? We need to search the entire database for all occurrences of item 789. So this just gives you some perspective that we want to be thinking about. So here are reasons anomalies exist. Several non-key attributes depend only on an item number. There should the dependence on the full prime key, which is the item number plus the order number. And so this is a scenario that we want to be thinking about. Okay, let's give an example of the second normal form for entities with concatenated keys. Do any attributes depend on just part of the key rather than the entire key? If yes, move the partially dependent attributes to a new entity. So thus now we have ordered items, and then we have specific items. And so now we're just breaking it up into more layers. What are some potential anomalies with the second normal form? The order entity contains transitive dependencies. Several non-key attributes depend on another non-key attribute and not on the primary key. We have the customer address, customer type, district number, and region number that depend on the customer name, not on the order number. The solution is to remove these attributes to a separate entity. And so this is what we would want to have us do. So here we have a customer. Now we have an ordered items and items. And so this is what we have. Do we have an attribute value dependent on an attribute that is not the entity's key? If yes, move these attributes into a new entity. And that's where we have it. Now we have a lot cleaner database structure by going through this normalization process. And I won't go through this chart again, but I just wanted to highlight that this is the normalization steps, and it's a good chart for us to finish up this short little lecture with that. Okay, thank you very much.